Hi, hello everybody, welcome back to another video on my channel. It's me, David, aka The Blue, and today we're going to learn how to solve derivatives. These are the main big four that I remember from taking my AP test. Let me know if I'm missing some. These are the ones that came to mind. But for now, let's start with a simple definition of derivative. This is what we're going to start learning. Uh, Sorry, let me explain what's going on here. I'm going to quickly erase this. We know average rate of time, sorry, not average rate of time, average rate of change. A rock is equal to change. Okay, sorry. Let me visualize this for you guys. Say this is point A and this is point B. And this is point F of A and this is point F of B. On like a straight line, right? In order to figure out the change from one point to another, where average rate of time says that at the very top we're gonna have f of b minus f of a, or b minus a, and this is just your normal slope, as in rise over run, change in y over change of x, right? So if that's a rock, the derivative is a rock as what was it? The point in one of these keeps reaching 0. So, like at a single point, because the derivative is the instantaneous rate of change. So, I rock is basically telling us that as the limit approaches, and we're gonna do h because this one's a whole lot more easier. As the limit of h of f, as the limit of f of x plus h minus f of x over h, as h approaches 0, that's going to be our derivative. And this is still our f of b, that's still our f of a. This is just saying, like, as the points keep getting closer. Anyways, I don't know if I'm explaining that part good, because I really haven't learned this since the beginning of last year. But anyways, knowing that, this is our definition of our derivative. So, how do we use it to solve problems? Usually on the AP test, you get asked to use a definition of derivative to prove that, like, for example, that this is equal to 1, right? You're going to get asked to use the definition of derivative. So, we're going to rewrite this as the limit of, as h approaches 0 of f of x plus h minus f of x is equal to h. So since our f of x is just equal to x, we're gonna do x plus h minus x over h, and our limit's still applying to this, so this is just gonna be h over h, which is equal to 1. So our limit as h approaches 0 is equal to 1, and since there's no h, this is just equal to 1. So we use that to prove that the derivative of dx, sorry, not the derivative of dx, the derivative of x is just equal to 1. On other problems where it's going to be like x squared, right, and y this equals 2x, we're going to take the limit as h approaches 0 of f of x. Since f of x is just equal to x squared, I'm just gonna, here, let me write that right here. F of x is equal to x squared. We're gonna do this, x plus h squared plus x squared, sorry, not plus x squared, minus x squared over h. So this is just gonna be 2x plus xh plus 2h minus x squared. Not 2x, sorry. I meant to rewrite this as x squared. Okay, I messed up really badly. It's actually x squared plus 2xh plus h squared. I don't know why I said 2x and 2h and just one xh. Anyways. Yeah. So we get rid of x minus, sorry, this is still over h. We get rid of x squared because that gets cancelled out by minus x squared, so we get left the limit as h approaches 0 of 2xh plus h squared over h, which we can rewrite that as, let me see if I can zoom any smaller. I can't. H times 2x plus h over h, get rid of that. So the limit, here, let's see, where do I have any space? I think I write way too big. Can I grab this? Sorry, wait, actually, let me make this. How do I move you? There we go. Anyways, we're gonna rewrite this over here as the limit as h approaches 0 of 2x plus h, plug in 0 into h, that's just equal to 2x. That's how you prove that the derivative of x squared is equal to 2x. And for this one, how you prove that the derivative of x is just equal to 1. Anyways, here we have power rule, and our mantra is that if you have x to the power n, if you want to take the derivative of that, then you multiply by the exponent and subtract the exponent by 1. So here we have a very long equation right here. We're going to take the derivative of this. We started with 3x to the power 7. We multiply our coefficient by 7, 21, and then subtract the exponent by 1, so 21x to the power 6. We did the same thing on the other side. 5 times 4, 20x. 4 minus 1, 3. So 20x cubed. Same for the other one. 6x squared plus 2x plus 1. And if you want to see the y, that x is just 1. In the terms of power rule, x of 1 is equal to x. So we're going to multiply by 1, and then this is going to turn into x of 0, which is just 1. So 1 times 1 is equal to 1, and that's why this is going to be your answer for the power rule. Here we have, sorry, that's not what I meant to do. Whoa, wrong page. Here we have product rule over here. This tells us that if you want to take the derivative of f times g, you have to, you'll have to multiply by the derivative of f with normal value g plus f times g prime. Sorry, I don't know why I just said normal value g. I could just say g. Anyways, let me write a problem for this. D over dx. That's a horrible dx. D over dx of x squared times sine of x. So in order to find the derivative of this, x squared is going to be our f, and sine of x is going to be our g, or f of x, g of x. So start off, we have f prime, which is 2x by power rule, and g of x, which is sine of x, plus x squared, just normal prime, just normal f, and then g prime, which is going to be cos of x. So this is going to be our answer for that. If you want, you could take the integral of this to see if you got it correct, but you probably won't. If you're trying to figure out how to solve these, you don't have to worry about that right now. Probably make a new video on that. Anyways, now how you do quotient rule. This is if you're trying to take the derivative of f over g. Now basically you do the exact same thing as the product rule, except that you subtract f times g prime and put it over g squared. So let's see, let's take the derivative of what we just did right here. Instead of it being x squared times sine of x, it's going to be x squared over sine of x. So it's going to be 2x times sine of x minus x squared times cos of x over sine squared of x. There we go. That is how you get how you solve derivatives, 4 different types of derivatives, which I think are going to be the main 4 on the calculus AB. Anyways, I hope you guys enjoyed, and I hope you guys understood. And if you have any more questions, leave them down in the comments below. Anyways, I'll see you guys next time. Goodbye.